right, so today we're going to talk about properties of logarithms. Before I jump into that, I just want to show you kind of where some of this comes from. So this is not going in your notes right now. It's just reviewing what we've done in the past. So if you think about what we've done in the past, if we had x squared times x to the third, what did we do with those powers? We added them, right? We combined them, so you'd get x to the fifth. All right, so I just want you to think about that. If we had x to the fourth over x, just x, subtract. What do I do? You would subtract. So it'd be 4 minus 1, and you get x to the third. And then one more. If I have x squared to the seventh power, what do I do with those?
Multiply.
Multiply x to the 14th. So I want you to be thinking about these when we go into the properties of logarithms. Because these special situations occur with the powers, when we put this into log form, some interesting things happen. And that's where some of these rules come from. And these rules are used a lot in higher level math, like calculus, to take something big and make it into something small. We're going to use it to help make some equations smaller. So I just wanted to kind of go through that first. So we're going to go through first and just talk about what the properties of logarithms are. So this is let b, u, and v be positive numbers such that b does not equal 1. And actually, I've decided I'm going to change those letters. So I'm going to cross that part off because I want to use different letters. I don't like using u and v because u's and v's sometimes look the same. So I'm going to use x and a and b. All right, so if I have the logarithm of base x of a times b, so this would be like the end part of our, this right here. We're multiplying, we ended up adding. Anyway, so we're going to go backwards instead of, and we're going to make this into an addition problem. So I could break this into two logs. Log base x of a plus log base x of b. So normally we don't want to break them apart as much as we want to put them together. So normally we'd be going from this to this, but we're going to practice both today.
That's called decomposition.
So actually what they call going from this to this, sometimes they call expanding the logarithm. And then if I go back this way, they call it condensing.
Synthesis.
So on your worksheet, you'll see those words. You'll say expand the logarithm, condense the logarithm. So if you're making it bigger, it's expanding. If you're making it smaller, that's condensing.
Like this.
Okay, the quotient property. If I have log base x of a over b, then you can take log base x of a minus log base x of b. So the subtraction has to do with what you do with the powers when you're dividing, like what we did over here with the x to the fourth and the x. We subtracted the powers. Remember, this is just a different way to write the powers, so that's where that subtraction is coming from. And then the power property is a really cool one that gets used a lot.
Is that supposed to be divide or just minus?
This is divide right here. This is minus, that's divide.
That's weird.
So if you have a divided by b, then you subtract. Because this is what you do with the powers. If you're dividing something that has the same power, this all has the same base, so we're subtracting. Because these numbers, so it's related back to those exponent rules. I'm not explaining it very well, but that's why it is the way it is. Okay, so log base x of a to the b power. There is this really weird rule where this b can be taken out in front of the logarithm. Okay? And it just multiplies. So if there's a power on this number, I can stick it in front of the logarithm. And that's just sort of a cool thing that works. We use this a lot when I was doing calculus in college. So if you're thinking engineering, or I know math majors probably not, but if you're doing any of those things, this is a trick that we use a lot because it can help you get rid of powers when you're solving for something. Okay, so I'm going to take you through several examples of how to expand and condense logarithms. And then next week, one of the final things we'll be doing with this is solving equations, and we'll be using this to simplify our equation so that we can actually solve for x or a or whatever we're looking for. Okay? It's not. All right, so look at this. So I want you to see first that there is a division bar here. Okay? So that's what I want you to think about first. So what we're going to do is we're going to, it says write as the sum, difference, or product of logarithms. Simplify if possible. A simpler way to say this would be to expand the logarithm. So we're going to write this as more than one log. So the first thing I'm going to do is I'm going to break this into 2 logs using that division bar. So I'm going to have the little 7 that's on there has to go with both. So log base 7 of 6 minus log base 7 of x cubed y. Okay? Okay, it's not. So we went from a division to a minus sign. You just rewrite it. Now, when you get done, each logarithm will either have just one number or one letter here. No powers, nothing on it. So this part's okay. I'm going to copy that down over here. Way over here because I'm going to need some room. All right? Now, I'm going to take apart this logarithm. Now, technically, we are subtracting this whole thing. So when I break this apart, this is, I'm going to have a minus sign and I'm going to do some parentheses. So see how I have x cubed times y in here? You could put a little times sign. If I break the x cubed and the y apart, that would make it into an addition problem. So I'm going to have log base 7 of x cubed plus log base 7 of y. So I broke apart the division first. Then I broke apart that multiplication. Really, you're just writing a log base 7 on each one and expanding it. Okay, so really quick, where did the what go? It's still right here. We just copied it down. So this part expanded into both of those.
Wait, so
all right?
use like logarithms for like I know they use.
You use them to solve problems where you need to find a power that's an x.
No, but I mean like in the future, like engineering and stuff.
I will show you when we're done with this lesson. I'm recording, so I need to keep moving. Okay, so we're going to distribute this minus sign. So this is log base 7 of x cubed. And I'm going to distribute that minus sign over here to make it minus log base 7 of y. I'm going to show you something else. Both of these are minus because they both originally came from the denominator. So if you're looking for a place where you could skip steps, and I know some of you are, you could go from here down to here pretty easily by knowing you needed to break this apart because they're both in the denominator. They both need to have a minus. Now, the only thing that's left, each of these need to be a number or letter with nothing on them. So there's a 6, that's okay. This y is okay. This x to the third, I need to take the third power off. So we're going to use that power rule that we just learned, and we're going to take that 3, put it in front of the logarithm. So your final answer is going to be log base 7 of 6 minus 3 log base 7 of x minus log base 7 of y. And that is my final answer. It's completely expanded. The only other thing you could do with this is if this 6 was actually a power of 7, we could actually compute what that number was. But since 6 can't easily be made a power of 7, we're just going to leave that. Okay? It doesn't simplify easily, not with anything that you know so far. So, okay, we're going to go through several of these, so just stay with me. Each one is a little different. All right? Each one's a little different. And I am showing lots of steps just so hopefully you understand where everything comes from. And then when you get used to it, it might get easier for you. You might be able to condense your steps down. All right, so the next one, it's the same steps. It tells us to do a sum, difference, or product. So here's what we're going to do. So I have log base 4 of 4x to the 6th over y. I'm going to combine these steps a little bit. Are you going to hang with me? So see how this is 4 times x to the 6th divided by y? I'm going to combine 2 steps into 1. Okay, so I'm going to break apart the top first. Log base 4 of 4 plus log base 4 of x to the 6th. It's plus because that was times. And then I'm going to go ahead and do the minus part with the division. Dividing by y, I'm going to make it minus log base 4 of y. So I did all of that in one step this time because I see multiplication and division. Anything that's coming from the bottom needs to have a minus sign. Anything that's coming from the top is going to be positive. Okay, now, shh. So I broke everything apart. Now I just need to see. I have a number here, and you know what? These 4s are the same. So do you remember that property where we could kind of cancel those? I need to know what the power on this 4 is. So that's 4 to the first power, and then these all cancel, and I just get 1. Whoa. So if you have just numbers here, those properties that we learned yesterday where you can cancel things or you can actually evaluate things, you need to do that. On the variables, you really can't. What could I do with this next one?
Move the 6.
Yeah, so you don't want to have any powers left, so we can move the 6 down in front. That's the power rule. 6 times log. So now I only have an x that I'm taking the log of, and minus log base 4 of y. I can't. So that's it. That's all I had to do.
Oh my god, yay.
It's done. So you need to break everything apart, and when you're done, each logarithm will only have a variable or a number here, and if the number is such that I could cancel this or evaluate this using things that we learned in the last lesson, you need to do that. That's where it means simplify if possible. With the numbers, I could simplify that. And that's 1 because 4 to the first power is 4. Okay?
Square root.
Yep, so I'm going to show you the next one. Now, shh. If you pay attention, I'm going to talk you through it. Don't complain before we get there. Okay, so we have log base 5 of 7 times the square root of x. So I'm going to put a little times there. So when I break these apart, I'm going to have log base 5 of 7. Since this is times, there's no fraction, so it's going to be a plus. Log base 5 of the square root of x. Okay, log base 5 of 7. 7 is not a power of 5. So I can't really simplify that without using weird decimals. We haven't gotten into that yet. On this, we can do something. A root is technically the same thing as a power written in a different way. So this is going to stay the same. This would be log base 5 of x to the 1/2 power. We talked about those powers a little bit yesterday.
Then 1/2 goes in front.
And then the 1/2 can go in front. And then that's all I can do with this. So it's log base 5 of 7 plus 1/2 log base 5 of x. I just have a 7 here and an x there. There's nothing left that I can simplify or condense, or I'm sorry, or expand. So that's
for
it.
clarification, why move the 7 over to the log on the first area?
So this is 7 times the square root of x. And when you have two things together, if you go back to that rule, when you break them apart, you break them apart and put a plus. You'll know you're done if each log only has a number or a letter. After the, so you have log base 5 of 7, that's just a number.
7 is not power of that.
Yeah, 7 is not a power.
Oh, okay.
So, okay, I wasn't getting what you're saying. It's not a power, so it can't go out here. If that 7 had like a power on it, then I could move it. Okay, so hold on to your hats. There's one more of these, and then we're going to do them backwards.
School. That wasn't funny.
Okay, sorry.
Don't make jokes like that.
All right, so the first thing we're going to do is we're going to take, you see how everything's in a square root this time? That makes us a little bit different. And there's no numbers, it's all letters. Okay, so the first thing I'm going to do is I'm going to write log base A, and I'm just going to make this all one big 1/2 power. Okay? So there's a z down there, and I'm just going to change it to the 1/2 power. Square roots is the 1/2 power. Now, there's a couple of things we could do with this. I could take that 1/2 power and distribute it to everything that's on the inside. Or I could go ahead and take that 1/2 and move it in front of the log and just leave it there.
Let's do that one.
That's what I was thinking. That's what I usually do. So I'm going to have 1/2 in the front, log base A, and then and that would just, everything that's in there is still what it is. We haven't changed it yet. But now I just have that fraction. So that 1/2 is going to have to be in front of whatever else we do. So for this next step, I'm just going to do it all in one step. I'm going to do 1/2. And I'm going to make a great big bracket to hold everything else I'm going to do. Okay? So then I'm going to break apart all these logs. So I'm going to have log base A of x to the 3rd.
That's a problem.
It will be in a second. Plus log base A y to the 5th.
Oh, man,
and then when divided by z, what do I do with that? Minus log base A of z. So the only thing that I now have to do is take care of the powers. You see I have a 3rd power and a 5th power. Okay, so make sure you understand these things are multiplied. They're in the top. They're positive when I break them apart.
Log A x.
Yep, so I'm just going to leave the 1/2 out there, and we'll have 3 log base a of x plus 5 log base a of y, and then the last part can stay the same. And you could, in theory, do both of these steps at the same time if you could keep track of it. If you can move the power down and separate them in the same step, I'm okay with that. And if you wanted to, you could distribute 1/2 to everything here and make this 1.5 and 2.5 and put a 1/2 in front of that. I'm just going to leave that out there. Like, that's kind of an optional thing. A lot of the textbooks, if you look in the answer key, just leave the 1/2 out there. Some of them distribute. It's sort of an optional step. Okay, so now we're going to go backwards, which means we're going to take something big and move it down to make it something smaller. Okay, so on the next step where it says write each expression as a single logarithm of coefficient of 1, that's a fancy way of telling you to condense the logarithms. Now, we can only condense them if they have the same base. We want to check 3, 3, and 3. We're good. We can condense it all. So we're going to make this into one big logarithm. So I'm going to have logarithm base 3, and the 5 and the x part are being added. So when I put them over here,
multiplication.
It's going to be multiplication. So I'm going to have 5x. What about the minus with the 7?
Wouldn't it be 5x to the 6?
We'll do that in a second. Oh, yeah, so it would be 5x, yes. And then we put, well, actually, no. So the 6 that's right here is only going to go on the x. So I guess I was putting parentheses. I was telling myself no. So it is 5x to the 6th power, so that's good. Not on the 5, just on that. And then divided by, good, 7. And so that's all we have to do. Condensing is more fun because you only have to take something long and make it something shorter. And this is typically what we're doing when we're solving these equations. Okay? All right? So on the next page, we've got 2 more examples. So before I put all these together, I want to think about the powers. If you have a number in front, that's going to become a power. Okay? If I have a number in front here, that's going to become a power. This one doesn't have one. Okay? And I want you to think about this. So they all are log base 8. So I'm going to make one big log base 8. Anything that's positive is going to get combined on the top. So this part and this part are positive. So I'm going to change this 3, put it over here, make that x to the 3rd. And then I have a 15. So I'm going to have x to the 3rd times 15, which I could just write as 15x to the 3rd. Those are all positive. That goes in the top. Did you have a question?
No.
Does that answer it? Do you get what I'm doing? And then the part that's minus goes on the bottom. So we move this 5 up there to make it a power.
Will it be 15y over?
So we'd have just y to the 5th on the bottom. And sometimes with these fractions, they'll put little parentheses on it.
Wait, whoa. Oh, wait, never mind.
So let me go through that again. Okay, so the first thing we did was we took the 3, made it a power here, made the 5 a power there. Everybody's good there.
Yeah.
Then I'm going through everything that's positive is going to get multiplied. That's going to go on the top of your fraction. So this part was positive. That's where the x to the 3rd came from. Then I had a 15. Since it's normal to put the number in front of the x's, I just flipped those and made it 15x to the 3rd.
Okay, so positive goes on top.
Positives go on top because those are the parts that are being multiplied. Anything that has a minus is being divided. That's going to go on the bottom. And so we'd move the 5 that made it y to the 5th on the bottom.
The next question is the same.
The next question is not the same.
No, it's not.
So it looks almost exactly the same, except I made both of these minuses. I'm going to show you. So we're going to take the 3, move it over here to the x, take the 5, move it over here to the y, and then I have, this is the only part that's going to go on the top. So it's all log base 8, but x to the 3rd is the only part that's going to go on the top because these are both minus. So what happens is those are going to get combined on the bottom. So I'm going to have y to the 5th, and I'm going to have 15 now in the bottom.
But they're dividing.
They are. So I'm going to do 15 y to the 5th. This is dividing both of them.
Boom.
So if they go in the
So
bottom,
it's the exact
that's the
same.
part that's dividing.
So it's the exact same for you.
Pretty much.
Except that that minus sign changes.
It's like the 15.
Where the
went to
15's
y
gonna
instead
go.
of the x's.
Oh.
So the 15 went in the bottom
So
because it has a
instead of y-
minus instead of a
So
plus.
y to the 5, 15 is 15.
Okay? I'm going to stop there.